Okay, so I think today's plan that I'm going to finish the SQL programming review. So we will not able to cover every slide, but I'm going to pretty much focus on SQL programming. So in the last class, I think we kind of at the end of last class, we kind of discussed the comparison operator used in subquery. So we discussed how to use in, and also we learned the new comparison operator, like we combine the comparison operator like greater than, equal to, or less than equal to, with some keywords like any, some, and all to form a logic. So basically, equal to any or equal to some operator basically is more like an in operator. So it's compare a single attribute with an attribute value with a list of values. So as long as the attribute value is in that list, then this equal to any or equal to some will return true. Another one is that we use like a greater than equal to all or less than equal to all, this logic to trying to compare a single attribute value or single value with a list of values. So for example, if the single value greater than or equal to all of the values in the list, then it returns true. So this less than equal to all basically compare a single value with a list of values. As long as the single value is less than or equal to the all values in the list, then it returns true. So these two logic usually used to find out the minimum values, the maximum values or minimum values of a list. So we are going to see some examples to see how to use those operators to find the information we need. I think, okay, this kind of we ending last time. We kind of use greater than all. So this query trying to find employees whose salary is higher than everyone in the of the employees in the department file. Okay, so that's why we use greater than all to try to find an employee salary is greater than every salary in the department file. And for this example, okay, so for this example, it retrieved the assistance of employees whose salary are not the lowest. So how do we know if an employee salary is not the lowest? I think we can use two different methods. One is that recall we do have aggregate functions that are able to produce the minimum and maximum values. So then I think in order to answer this question, we may have to the subquery. So the inner query or the subquery is to produce, for example, the minimum salary of the whole company. Then the outer query trying to filter the employees. So basically only retrieve the employees whose salary is greater than the minimum salary of the company, so that those employees whose salaries are not the lowest. So this is how we can write this query. So we can use two different methods. Okay. For example, it's asked for the SSN, so we need to use the employee table. So that's the table contains SSN and salary. So then we compare each one's salary, with the minimum salary of the whole company. So in order to generate the minimum value, so for every aggregate functions, they cannot use by themselves. So they have to be embedded in SQL query. So in the past, I have seen a lot of students just trying to call this minimum. That's not right. So we have to embed the minimum within the standard SQL query. So that's what I mean. So that we have to use standard SQL query. So here we have the minimum salary. for example, this is called a standard. So we have select minimum salary from employee. So then this minimum aggregate function will generate the minimum salary of the whole employee table. So if there are multiple people having the minimum salary, that's fine. And this minimum function only generates a single value, okay? So then the logic here is very it's very kind of straightforward. So we use subquery to produce the minimum salary. So again, we have to embed this aggregate function min into a standard SQL query. We cannot call it directly. We cannot call minimum salary directly. Okay. Then the out query just compare each employee salary to see if an employee salary is greater than the minimum. If yes, then we find out those employees whose salaries are not lowest. So this is one method, or we can use the comparison operator. Like, for example, the auto query is still the same, so we have to use employee table, and the subqueries is a little bit different. So sorry, I probably have to condense. Okay. So then we compare the salary. So if we, for example, greater than sum, so here we use greater than sum, this comparison operator, okay? So basically, the logic here is that the inner query, instead of produce the minimum salary, this inner query just simply provides a list of all salaries, okay? Then the outer query, we will go to compare each employee salary with this list. So as long as an employee's salary is greater than some salary in the list, that's guaranteed that this employee salary is not the lowest. Okay, so for all the salaries satisfy this condition in the work clause, that's guaranteed that that salary is not the lowest. So then we're going to output corresponding employees assistant. So that's how and also greater than some or greater than any are the same. Okay, so some and any can be used interchangeably. So pretty much they mean the same thing. Okay, so depending on, so to me, I think some makes more sense to me, but it's up to you. So whether you want to use some or any, so that's fine. Okay, any questions? Okay. So I think for this in-class exercise, these two are pretty simple. So for the department that controls the project new benefits retrieved its manager's assistant. So it's talking about the project new benefits. So we have to go to the project table here, I think. Okay, so we just examine what are the attributes in the project table. So we have project number, project name, project location, and DINA, so controlling department, okay? It's asking us for the controlling department manager's assistant. So we know that project table itself is not enough. So we have to combine the project table with department table. So it means that for every, for example, project record, if we're able to combine the corresponding department record, then we're able to retrieve the manager's assistant, okay? So that's basically the idea how we can write this query. So it's asking for the manager's assistant. So at least in the from class, we have to have the project. Yeah, I'm confused. join. Okay, project, join, department. Okay, then on. So we need to specify the join condition. So it's up to you. So you can type like the project.denom match department.denom. I think that's fine. Because here, if you examine the attributes of the project and the department, and they don't share any common attributes, so it means that each attribute is kind of unique. Each attribute's name is unique among the two tables. So if that is the case, you can, for the denom in the join condition, denom and d number, you can basically specify them without identifying the table name. Okay, so in other words, you can strictly have denom match the d number. Okay, so that's another way you can do that. Okay. Then here, we are not interested in every manager's SSN. We're only interested in the controlling department who controls the project called new benefits. Okay, so that's why we're going to, in the where clause, we're going to specify the key name equals to new benefits. Okay, so in the select clause, we just simply select actual SSN. Okay. Okay, so next questions. For the department that controls project new plan benefits, retrieve its manager's SSN, first name, last name. So this one is very similar to the one we just discussed. The only difference is that it's asking not only manager's SSN, but also manager's name. Okay, so that's basically what we need to do. Excuse me, I just need to make sure my daughter's school. I don't know if there's something wrong with her school. Okay. So now, so the only difference is just the manager's name. We also need to retrieve the name. So apparently from project table and the department table, we don't have any name info. So in this case, it means that once we have the manager's SSN, we also need to combine with employee table. So looking for the employee record whose SSN match the manager's SSN. So that means that we need to join 3 tables in order to answer these questions. Okay. So why not? I want you to think about it and write your own query so that we can discuss the answers. Okay, so I think if you follow the logic of the previous one, I think this one is also very straightforward. The only difference is that we have to join the three tables together, but that's other than that. So in the from class, we have to join the project. So the first join is department. D num equals to D number. Okay, so if you prefer, we can add the prefix each attribute with corresponding so if you don't like writing a long table name, then you can also rename. For example, I rename project to P and department to D. Then I'm going to have a P dot dnum equals to D dot D number. Okay. So in order for our query reads, clearly or easy to read, we can use parentheses indicate that this join will be performed first. Then we're going to further join the employee table. Okay, so you can also rename employee. You can rename a table to any kind of anything you want. But since we do the renaming, we want to save us from typing a long table name. So that's why usually I just use a single letter, but you can have freedom to pick, whatever name you want. It's not necessarily a single letter. So then we need to join employee. So then this time we have to make sure that the employee is SSN match the department manager's SSN. So the manager SSN. Okay. Then still we have the join the selection condition means that we're only interested in the project whose name is new benefits. So that's why we can have P name. And if you want, you also can use P dot P name. So it's really equals to new benefits. Okay. Then in the select class, we have to have the manager's SSN. So you can have E dot SSN. Or you can use D dot MGR SSN. But E dot SSN and D dot MGR SSN, these two will have identical values. The reason because of this join condition. So that's we'll make sure that when we combine the department record with employee record, so these two attributes will have identical values. So that's why when you select, you can either do the D dot MGR SSN or E dot SSN. Okay. Then you have E dot F name and E dot L name. Okay, so that's it. So let's run this command, make sure that this is working. I think the only thing right now we're going to have error information is the single quotes. So just change the single quotes. Okay, then let's run to save. So we are expecting there's only one record because there's only one project whose name is new benefits. So pretty much each project has also a unique name. Okay, I think that's it. So now I think I want to discuss a little bit extra features of Oracle database. I think for the MySQL, I am not sure. Let me search. I know in the past, MySQL does not support set operation. Okay, good. So, okay, that's very nice. So I think several years ago, Oracle is the only one support the set operation, and MySQL does not. But anyway, all the set operations we discussed here basically can be rewrite without using them. But because of the set operation, that's make us writing SQL query in a much kind of simple way, okay, and also simple flow. Okay, so set operation basically are used to taking the union, intersection, and differences of the two tables. So the union of those two tables, pretty much you simply merge the records of two tables together. So this figure shows what the union looks like. So we have a table R and a table S. So in this example, the table R and the table S has some common records. So that's pretty much the overlapping here, okay? So if we try to union R with S, pretty much the result will contains every record in R and every record in S, okay? So for the overlapping, so they also be included in the union. So if you can distinguish the parts in the union, that's probably will be better. So the color R, I mean part of the R that in the blue color that indicate the records only in R, okay, unique. And the parts that marked in red, that's basically shows the records only appear in S. Then in the middle, that's basically indicates the records of the overlapping part. That means that records appear both in R and S, okay? Then this shows the intersection. So intersection, we only try to find out the common records of the two tables. So that's the overlapping part, okay? So given R and S, intersection only get the overlapping of R and S, okay? So means common records in both. Then this is the two set operation. The third one is called difference. So difference basically really kind of retrieve the differences between the two sets. But we do have order. For example, if we have R minus S, so that's basically we produce the records only in R but not in S. Okay, so this shows the result of R minus S. So it means it's pretty much equals to that. Given an R, we're going to subtract the overlapping between R and S from R. So this red part just indicate the records only appear in R but not in S. Okay, because if it appears also in S, that's the overlapping part in the middle part. But the middle part is not in the result. Okay, and this shows the S minus R. So it basically try to retrieve the records only appear in S but not R. So if there's overlapping between R and S, then the S minus R will only contains partial S. That means the records only in S. So the overlapping part will not be appearing in the result. Okay. So I think this three-step operation so make us as convenient to us to combine multiple query results together to produce what we want. Okay, but before we're able to use the set operation, we have to be careful that the two tables that we apply the set operation must be union compatible. By union compatible, it means that the two tables must have the same number of attributes. And also the corresponding attribute should have the same data type and lengths. So I think that's basically, for example, in the database, we can store a field in the char string. When we define the data type of that char string, we can also define them like the length, the number of them, for example, number of the letters in the char string if we use the fixed length char string. But even we define the data type as a variable length char string, we also supply the maximum number of the letters in that char string. Okay, so then this number of the letters will be the length. Okay, so in essence, you first have to examine if the two tables have the same number of the columns. So if one table has 2 columns and other table has, for example, 3 columns, then you can never do the set operation. Okay, so the two must have the same number of columns. Then the corresponding columns should have the same semantics, same data type, and the same length. So that's very important. So that's called union compatible. So let's see the example here. Retrieve the SSN of employees who work on both project number 1 and the project number 2. Okay, so it's asking for the SSNs of the employees who are working on the project 1 and 2. So I think we have to rely on at least need the work sum table, because work sum table gave us the SSN of the employee along with the project number. Okay. Then the question here is that how can we know if an employee is working on both projects? Okay. We may have employee only works on project number 1. We also have employee may only work on the project number 2. And what we need is that we want to have the employee that works on both. So project number 1 and number 2. Okay. So I probably give you 2 minutes to think about it. Then we discuss the solution. So we can use set operation. We can also use the subqueries. So really depending on what you prefer. So the way of your thinking. So. Okay, so for this one, I think if we use set operation, so what set operation we should use? So we have union, we have set differences or minus. We also have the intersection. I think for this one, we probably have to use intersection. So intersect operation. So in order to use intersect operation, we have to produce 2 tables. And then we do the intersect 2 tables. Okay, so the idea here is pretty, I think it's pretty straightforward. We use one query to produce the ESSN works on and who's working on the project number 1. Okay, so select ESSN from works on where P&O equals to 1. So this query will produce a list of ESSNs who are working on the project number 1. Okay, then we can also use similar query to find out the employee SSN who are working on the project number 2. So we have P number equals to 2. Okay, so once we generate these 2 resulting table, so how do we know which ESSN appear in both results? So it should appear in the first query result and also second query result. Then we do the intersect. Okay, so intersect, this set operator basically tells the database, okay, you need to find the common records in these 2 tables. So the first table produced by the first SQL query and the second table produced by the second SQL query. So this is one way we can do that. Okay, so that's why I think the set operation is pretty I actually like set operation. So that's the reason I use Oracle before. I prefer Oracle than the sorry, than the MySQL. But right now I think MySQL and Oracle should be pretty similar because they all belong to the Oracle company. So if we do not want to use the set operation, then we can also use subquery. So that's, I think, in the SQL query, especially when you're working in the real world, a lot of time you probably have to, how do I say, a simple SQL query may not answer your questions. So you may have to manipulate to generate some kind of a temporary results and utilize that temporary results to produce kind of maybe another temporary result, and until you reach to the final results that you're looking for. So in this case, subquery provides a way that you can pre-compute some query, and then use the results in another query, and then you can embed it several subqueries into one SQL query to pretty much to produce what you want. And for this one, I think the idea here is very similar. So, for example, we can first identify the employees who are working for the department, for working for the project number 1, okay? And then once we find those one, we can basically find to examine if they are also working on the project number 2. Okay, so sorry. I think I forgot about this one. So let me just make this double column. So So here we can, for example, do the similar thing. So first one, we trying to find out the employees SSN who work on the project number 1, okay? Then we also want to make sure that the employee SSN also working on the project number 2. So how can we do that? We probably can do the SSN in. So we're going to examine the same SSN also work for the project number 2. Okay, so in this nested query, we simply just produce a list of SSN who working on the project number 2 also. So we can have select SSN from worksum where PMO. Actually, the reason I'm doing the indent, I mean, just simply make the query easy to read, but it's not necessary. So you maybe do the semicolon to end the query. Maybe I make the DB smaller so that it's easier to read. Okay, so this is the second way we can write this query. So in the second way, we do not use the set operation. We just use, we call the nested query or subquery. Okay, so this can be thinking as a subquery. So this subquery produce a list of SSNs who working on project number 1 and number 2. Okay, then this result will be used by the auto query. So the auto query will examine every record in the worksum table. First, that record PNO must be 1. Okay, then it's also examine if that same employee also appears in this list, SSN list. So if yes, that indicates that employee also work on the project number 2. Okay. Questions? Okay, good. So I think there's maybe one more. I know a lot of you are pretty advanced in the SQL programming. Sometimes I think the last one you can do the self join. Okay, so I may need to make it smaller so that I'm able to do the self join. For example, select. So I'm going to join works on 2 times from works on. I call it P1, for example, and join works on P2. Okay. Then so basically if I join works on myself, I want to make sure that they have the same ESSN, okay? So the 2 records, one from P1, one from P2 must have matching ESSN, okay? Then I also want to make sure that one product number is P1, another one product number is P2. So that's why in this one we're going to have P1 dot PNO equals to 1 and P2 dot PNO equals to 2. Okay. Then for the result, we simply just print pick. For example, I use P1 dot ESSN. You can use P2 dot ESSN because both are the same because of this join condition. Okay, so there's another one we can write this query. That's just for your interest. If this one's too much, just forget about it. Okay, I just want to show you sometimes self-join may be also provide a way for you to find the information you need. Okay. Okay, now we discuss the example of the set difference. So retrieve the SSN of employees who are not supervisors. Okay, so how do we know an employee is not supervisor? If we can, I think the same thing. This query can be answered by using set operations or not. Okay, so we're not using. Okay, so for this one, if we use set operation, we basically, for example, it's asking the employees who are not supervisors. So one way we can do that, first we can go to the employee table to identify a list of the employee SSN. And the second, we can, sorry. So then second one, we basically find a list of supervisors SSN, okay? So then we can do the set differences. So we can subtract supervisor SSN from the list of the SSN. So then remaining will be the SSN who do not appear in the supervisor list, okay? So this is the kind of idea what we're going to do. So we do the select. First, we generate a list of SSN from employee, okay? Then we're going to also generate a set of super SSN also from employee. And that's the attributes that we can find from the employee table. So employee table contains both SSN, also the supervisor SSN of an employee. Okay. So once we get these 2 sets, we can do the minors. Okay. So this minors is doing that. It's just trying to find given a list of employees SSN, it will take out the super SSNs from that list. So the super SSNs will be produced by the second list. So pretty much it will subtract the SSN, the list of SSN, subtract the list of super SSN from the list of SSN then the remaining will be the assistant who are not supervised. Okay? And the same thing, we can answer this question without using the set operation. Okay, so the idea here is that, okay, we find everyone's assistant, then we want to make sure that assistant not in. Okay, then in the query, we just produce a list of super assistant. That's it. So this nested query or subquery, you produce a list of super assistant. Then the out query, it will examine every employee assistant to see if that assistant not in the list. If that assistant in the list, that means that that employee is a supervisor. But if an assistant not in the list, that means that that assistant is not a supervisor's assistant. Okay? Questions? Let's see some example here. So find the names of employees who are not department manager. So it's find names of employees who are not a department manager. So for this one, we can also, I think we can also use set operation or not. Okay, let me just duplicate these. No, so I just keep it. Okay, so the first one is asking who are not department manager. So we know that in the department table, we do have, are you able to do it? Yeah. We do have a manager's assistant, okay? So one thing we can do is that, I think probably either way is that we do not use the set operation. So we go to the employee table, we retrieve the employee's name, and go to the employee table. We compare the employee's assistant with a list of manager's assistant that can be retrieved from the department. If an employee's assistant not in that list, that means they're not department manager. Then we can print out their name. So we have select add name, L name from employee. Okay. Then we will examine assistant to make sure that assistant not in. Select MGR assistant from department. So that's all we need to do here. Okay. So this is kind of idea. I think when you write SQL query, you first just form the logic how you can retrieve the information correctly. Then you just need to pretty much translate your logic into the SQL query. Okay, so let me make it a little bit bigger. Okay, so this is how it will be. The second one, also, if you really want to use the set operation, yeah, I have to shrink it down. Okay, then we can do maybe is that so we are able to get each employee's name, but for the department manager, if only from the department table, we will not be able to get the manager's name. So in order to get the manager's name, we have to join department with employee table, so that when we do the set operation, we make sure that we kind of have unit compatible. Okay. So another thing we can do that add name, L name from employee. Okay. So this will be the list of employee's name. Okay. Then we also need to find our department manager's name, then we can do the set managers. Okay, so in order to get the department manager's name, we have to do the join. So we have to join, for example, employee. I think the order of join is not very important, but maybe the order of the table can help you to understand the join maybe better. So the join department with employee MGR SSN match SSN. Okay. So in this case, the second query also produced two-column table. The first column is F name, second is last name, and the first query also produced the table of the same schema or same structure. Then they are unit compatible. Then we can do the managers. Okay, so the managers simply subtract the manager's name from the employee's name. So the remaining will be the employee who are not the department managers. Okay? Questions? Okay, the second one, for each department, for each project, retrieve the project name, location, and its controlling department name. So I think this should be the simple join query. It's asking for the project name, location. I think those information can be found from the project table. Controlling department name, so that's not, because we only have the controlling department number. Then it's easy. We just simply join project with department so that we're able to retrieve for given D number, we're able to retrieve the corresponding department record. And from that record, we're able to get the department name. Okay. So this one has nothing to do with set operation. So we simply just join two tables together. So we first define a join. So we're going to join the project with department. Then on denom equals to D number. Okay. Then once we finish joining, we just simply print out it's asking for the project name. That will be the P name. Project location will be P location. And department name will be D name. Okay, that's it. Any questions? So I think we don't have much time, but we do need to have some discussion. So then the join the table. So I think we kind of discussed. So basically, you can either use join the table. That means that you specify, you use join table 1, join table 2 on this syntax to specify the join the table. Or you can use like table join. So we simply just list the table in the front clause, but we have to specify the where clause in the specify the join condition in the where clause. So I think maybe for the beginner, this one will be better. So it tells you that whenever you join two tables, you always have to have the on statement to define a join condition. But if you use this format, I think sometimes it's easy to forget specify the join condition in the where clause. So maybe if you're the beginner, I strongly encourage you to write query in this format. Okay. And also there's several different types of join. One is a natural join. So natural join is a very special case. So it means that when we join two tables and the two tables have some common columns, so it means the attributes with the same name, then our join condition will be pretty much specified on those common columns. If that is the case, then you can use natural join. So the natural join, you do not need to specify the join condition. So it means that you do not need to have on clause, but the database will automatically find the common columns and then of the two tables and then use them as a join condition. Okay. The inner join basically is considered as the default type of join. So that's how we use this join. So whenever we only have join, that means inner join. So inner join basically means that a tuple is included in the result only if a matching tuple exists in the other relation. Okay, so that's basically what is inner join. So far all our join examples are the inner join. Means that the join result only contains each record in the join result contains one record from the first table and the second record from the other table. Okay. So, and also the two records have the matching values on the join columns. So that's the very important condition. But if a tuple in table A does not have any record in table B that have the matching values on those join columns, then that tuple will not be appeared in the result. I think in the last class we kind of discussed the inner join and outer join. So outer join, basically we can either have a left outer join or the right outer join. So the left outer join basically means that every tuple in the left table must appear in the result, even regardless if that tuple has a matching record in the other table. If yes, that's good. If no, then we would pad the null values for the attributes in the other table, okay, or in the right table. The right outer join basically means that every record in the right table must be maintained in the resulting table. So if a record in the right table does not have any matching record in the other table, we just simply pad the null values in the fields of the other table. Then we have full outer join. So full outer join basically means that in the join result, we have to keep every record for the left table and every record for the right table. Okay, then if a record does not have a matching record in the other table, we just simply pad the null values on the fields of the other table. Okay, so I think this shows I think we have discussed this one already, but it's no hurt. Let's show this result. Okay, so it's depending on what you need. Okay, so for example, this one trying to output every employee's the first name and last name and his or her corresponding supervisor's first name and last name. So we use left outer join. So that means that all the records in the employee table will be appeared in the result, regardless if that employee has supervisor or not. Okay. So I think it is not do the. Maybe even without alter. Let me see what's. Okay, that's not it. Yeah, it's fine. So in this case, I think there's one, like James Burke. He's one of the employee, but he does not have a supervisor. So in this case, his supervisor field will be pad in the null values. Okay, and if we change it to the right outer join, so that means that every employee on the right table S will appear in the result. Okay, so because in the employee table, some employees are not supervisors, some are. So for those who are not supervisor, their name still appears in the last two columns. So because that's appear in the result, but the corresponding fields for the employee for the supervisee will be pad as null. So if we run this one, what's wrong? Right object, that's everything. So let's run again. Maybe the network. Yeah. So I think because of the weather condition, maybe the network is not that smooth. So sometimes if you sure that your query should produce right result, but you got some error information, don't feel discouraged or panic. You probably just run it again. I think maybe in one of my class, I'm not sure if this class or my other class, I have to run several times before it's produced no error and the results. So that's on the condition that you know that your query does not have any error information. So in this case, I think you're going to see every employee appear in the last two columns because that's basically the second table, employee admins, okay? Then because they're supposed to be the supervisors, then some supervisor does not have, some employee is not a supervisor. So that's why their supervisee field, so the first two columns will be padded as null, okay? So I know this is, will be more than 10, so that's the results more than 10 records, okay? So now we have 3. So basically, in this case, for the employee who are the real supervisors, their supervisee field will have values. For the employees who are not supervisors, their supervisee field, the first columns, will be null. Okay? Questions? So I think we still have some time left. So I want to discuss maybe the first one, the aggregate function. So once again, aggregate functions can only be used either for the when you first partition the records in the table to groups, then you apply the aggregate functions for each group, or you treat the entire table as one group, then you can apply aggregate functions. So aggregate functions simply produce group statistics. So once you group the records using the group by clause, you won't be able to retrieve the individual records information. So that's very important, okay? So, and also null values will be disregarded. So if the fields, for example, you count, you do the sum, you do the count, then the null values will be ignored, okay? I think find the sum of salaries of all employees for the research department as well as maximum. So I want to skip this one first. I want to find the one. Okay, because I think some of you submit the assignment number 4 already. And like I said in the previous class that you kind of, when it's asking for the like maximum value, minimal value, I think I see a lot of practice that you first generate the values, then you do the order, then you just output the first one. So although nothing wrong with the query, but I think in practice that query will not be the very efficient way because order the resulting table is very expensive kind of operation. So for this one, for example, for the department with the most number of employees, retrieve its department numbers. So how do we know the most number of employees? So I think we have seen the similar examples. So we can either use the aggregate function to find the maximum values, or we can use the comparison operator like greater than equal to all, for example. Okay, so for this one, we first use the aggregate, the subquery to find the maximum number of the employees for the department. So we're going to use the employee table because that's the table contains the employee and also the department number. Okay. So then we need to group by the employee by DNO because with that DNO, maybe also do the count. Okay, with that DNO, once we group the employee records by DNO, then we're able to count the number of records for each group. Okay, so then we have to, because we're only interested in the group having the maximum number of the count. So that's why we can have hiding clause and the count. Then one way we can do that, we can do the equal to the maximum. So in a subquery, we simply generate the maximum count. So what we can do that is very similar to the out query, okay? But we do the count and then we do the max. So that's called max count, okay? Then the same thing. So we're going to use employee table. We also need to group the employee records by DNO. So that's it, okay? So this, excuse me, in the query. What's the inner query will be processed is that it first group the employee record by DNO. Okay, so it's formed several groups. Then it's produced count for each group. So we have several counts. In this case, since we have three different department numbers, so we can have three groups. So when we do the count, it will generate three counts, one for each group. Then the max aggregate function will be applied to the count. So you get the maximum count. So that's the department has maximum number of employees. So then the auto query, we do the similar thing. So we still go to the employee table, group the employee record by the DNO. Then we going to examine the count of each group. So having count star. So this will be applied to each group to compare with the maximum. So if the count equals to the maximum, that indicates that's the maximum count. So then we produce corresponding DNO. So that gives us the department number that has the maximum number of the employees. Okay. Okay, so let's run this one. Then we get the department number 5 has 4 employees. So in this case, we do not need to order. I think the computation here, we only need to produce the maximum value and then compare with that. Okay, so this is the one way we can write this query, but there's another way. Let me see, yeah, I think you can see it. So the second way we can write this query, sorry, need to make so the similar, so okay, so we have select, DNO, count. So the similar logic. So we need to go to the employee table to first group the employee records by DNO. Okay. Then for each group, we compare the count. Okay. Then this time I use greater than equal to all. Okay. So then the inside, this all basically a list of the counts. So inside, I just need to, the same thing, I just need to generate a number of counts. Okay, so it needs to count for each department. So this is a second way we can write this query. Okay, so I think right now we afford to give them much larger fonts so that. Okay. So this first way, the inner query just simply produce a single number, the maximum counts, and then use maximum counts in the outer query. Okay, to compare with the counts of each group. The second method we use is greater than equal to all. Okay, so this can be used to, like as in the discussion, I said we can generate the maximum. So pretty much the inner query or subquery produce a number of counts or list of counts, one for each department. The outer query also produce count, and then it will compare each count with this list. If the count is greater than equal to all the counts, so because we have greater and equal to, so means that if a count is maximum, it will equal to the maximum count in this list, and then greater than the remaining count in the list. Okay, so we have to use equal to. Okay, so then I think it will simply produce the same result. So let's test this one. Everyone. Still the department number 5, count is 4. Okay, so this is actually the one that we can use. So if you compare, then I think I probably prefer the first one. It's maybe but easier to understand. But you have to know that you can cascade multiple aggregate functions together. So you have to understand the max count means that you first generate the count for every group, then you do the maximum count. Okay, produce a single maximum value, and then compare with the count produced by the output. Okay. Okay, good. Any questions? Okay, if you do not have any questions, then we are done today. Thank you.